Okay, another example. The diffusion coefficients for silver in copper are given at two temperatures. So silver diffusing to copper and diffusion coefficient at different temperatures are given to us. (650 degrees C), the diffusion coefficient 5.5 times 10 to the power of minus 16. At 900 we expect it to increase, right? It increases to 1.3 times 10 to the power of minus 13 meters square per second. In the first part A, the question asks what is determine D naught and Q. Activation energy for diffusion. In the part 2, we are asked what is the magnitude of diffusion coefficient at 875. Oh my god, what is it? That's what is asking, right? Okay, so let's see how we can do that. So if we look at what is given to us, we are given at different temperatures different diffusion coefficients, and we know the equations that relates the diffusion coefficients to temperatures. And if we can write those two equations and then correlate them to eliminate D naught, like we did before, and this way if we eliminate D naught, there's only BQ as the unknown, and from the information given we can calculate the Q. So let's solve the first part, okay? So I know I can write this, right? I can also write this one. So these terms are the same in both, and if I make it equilibrium, if I subtract these from each other, actually I can cancel ln D naught, and this way there will be only one unknown, which is going to be the Q in my equation. I'm sorry, this is of course minus, because minus times minus, it has to be plus, right? Okay, so other side. So let's solve this for Q, because that's what we are trying to get. This term goes to the denominator here. And R comes here, minus R. Okay. Okay, so that's it. And what we need to do is now plug in the information we are given and calculate the activation energy first. Okay, so Q. This is R. D D1 is given, right? We check, yeah. So here, and then denominator 1 over T1 minus 1 over T2, and solve it, and then you get this. So good, now we figured out the activation energy, but then question was also asking the D naught, right? And in that case, you can either use one of these equations, right? Either use that or that. It doesn't matter, but we can find D naught from one of these equations since both have the same D naught. So we can write D naught is equal to what? We cannot write that, right? Let's solve it using D1. D1 is equal to D naught. All right, plug it in. D1 is given as 5.5 times 10 to the power of minus 16. D naught is what we are trying to figure out. Q is what we found. And T1 is 923 Kelvin. Okay, so you guys do that part and calculate D naught. So I found D naught to be 4.007 times 10 to the power of minus 27. But I think you guys do it again because I did it myself. I don't have the solution manual. So, and I hope it's right, okay? You guys again do it yourselves. Alright? Okay guys, actually I figured out a mistake here. I'm sorry. Okay, so there is minus sign here, right? I forgot that. So be careful. So my mistakes are a lesson for you. You don't do that in the exam. That's why I'm doing mistakes, right? All right. So the answer should be 7.5 times 10 to the power of minus 5. All right. That's it. So we found Q and D naught. And let's see what was asked in the second part. It is just asking us the diffusion coefficient at certain temperature. It is very easy for us to do that because all I have to do is plug it in the formula. That's it. Okay, formula is again D is equal to D naught exponential minus Q over RT. And D is asked, D naught we found it. Okay, so solve it and it should be 8.3 times 10 to the minus 14 meters squared per second. That's it. Okay, this was another example.